All right, as we move into chapter 3, we're going to be talking about, we're going to get further into the concept of angles. And not only angles, but their relationships. You're going to be introduced to different types of angles now that are formed by different types of lines. The first type of line that we're introduced with is a parallel line. You should have already been introduced to parallel lines at some point in your math career, but in case you weren't or in case you forgot, two lines that never intersect and are not coplanar. They never intersect, so they run alongside each other in the same direction at the same rate or the same slope. We can tell that things are parallel lines because we see these two little lines. We can say like N is parallel to M. Those two little lines telling you that those two lines are parallel. Another type of line that you're going to be introduced to is skew lines. Skew lines are two lines that never intersect and are not coplanar. The fact that they never intersect does not mean that they're parallel. As we're going to see in example 1, skew can mean that they are completely opposite. The fact that they're in different planes is what's so important. And the next thing you're going to learn are parallel planes. And this is the exact same idea as parallel lines, except it's planes. There are two planes that never intersect. Remember that a plane is made up of four lines that go off in their directions but never stop. A plane goes off in every direction but never stops. The edges go on forever, but because we're limited to a piece of paper, we have to limit the plane to usually a rectangle or a square. So here we have this three-dimensional box, and this three-dimensional box shows us we have four planes, or excuse me, six. We have this plane, the side, the bottom, the side, and then we have the back and the front, or the front and the back, depending on how you look at it. But each one of those goes off in every direction forever. And so we have to be able to three-dimensionally think about, where does not only line CD go off, but where does that plane, that side plane, where does that go off? And that way we can figure out, parallel, perpendicular, and skew planes and lines. Let's just jump right in trying to identify. Number 1 wants us to identify lines parallel to one line or lines parallel to line CD and containing point A. The first thing I want you to notice is there's line CD right there. And here's point A. What I need to do is identify lines that are first parallel with CD. Well, the first line I see is line EF. I also see line AB, and I see line HG. Are there any more that are parallel to CD, meaning they go off in the same direction? I don't see any. So, I have three options. That problem wants me to find parallel line to CD and containing point A. If this is point A, there's only one line that is parallel to CD and contains point A, and that is line AB. Let's just erase all that. That way it doesn't bother us on our next problem. The next one, we want to identify a line or lines skew to CD. Remember, skew means that they never intersect and are not coplanar, meaning they can't be in the same plane. Skew to CD and containing point A. Again, here's point A. Again, the definition of skew means that they never intersect. So we could be talking about parallel, like AB is. We could also be talking about lines that go off in general directions. If I look, CD is going this direction. AH is going in this direction. Remember, each one of these lines goes off forever. AH and CD are never going to touch. You might say, well, it looks like they're going to touch up here. Remember that these are three different planes, or these are in different planes, meaning CDEF is off to the left, ABGH is off to the right. This line is going to be going up forever. This line is going to be going across forever. They will never touch. Think of it like the sides of a cereal box. If you have the top left corner and the front right corner, and you drew a straight line going up and sideways on those lines, Those two lines will never touch. We also have this line right here, AG. And again, you might be saying, well, it looks like they're going to touch right here. It looks like AG is going to run right into it. Remember that there's a gap in between these two sides. This plane over here and this plane over here have a gap in between them. AG, although it's running this direction, will never touch CD because it's in a completely different plane. So we're given three different lines. We're given AB. Make sure you label it as a line. We have AH. And we have AG that are all skew to line CD and contain point A. And again, skew means they will not intersect, which is like being parallel, but they cannot be in the same plane. So, number 3 is talking about lines perpendicular to CD. Let me erase all this. That way you can see our diagram a little bit better. Number 3, lines perpendicular to CD and containing point A. Perpendicular, talking about they meet at a right angle or a 90-degree angle. Now, I told you before that you can always tell a 90-degree angle because it's got a certain little mark on it. It's got the little red box, or just a box. It doesn't have to be red. But what we're trying to do now is we're trying to find right angles that intersect line CD and contain point A. Again, here is point A. Here is line CD. Are there any lines that intersect CD at a right angle and contain point A? Well, let's go through and identify all the lines that contain point A. We have AB that we've identified before. We have AG. We have AH. But then we also have DA. DA is the only one that intersects line CD. We can see that it intersects at point D. Line DA and line DC intersect at point D. I can also see there's a little 90-degree mark here, which means that those two lines intersect at a 90-degree angle. If they intersect at a 90-degree angle, then they have to be perpendicular. That's what the definition of perpendicular means. So, line DA is the only line perpendicular to CD and contains point A. Let's look at number 4. A plane or planes parallel to EFG and containing point A. First of all, let's identify EFG. Here's point E, here's point F, here's point G. The plane that connects all three is this plane right here. Okay, it could be the bottom of our box if you want to see it like that. And if this is still point A, we are looking for planes parallel to this bottom plane, which goes off in this direction, this direction, this direction, and that direction forever. We're trying to find a plane that is parallel to that plane and contains point A. Well, there's really only one plane that is parallel to it, and it's this top line, or this top plane, excuse me. It could be plane DCA or CDA, DCB, however you want to label it. Remember, we use 3 letters to name a plane. But this plane, we'll label it like that. That way you can see the contrast. It goes off in that direction forever, that direction forever, that direction forever, and that direction forever. And it contains point A. Those two planes are parallel. Again, think of it like the top and the bottom of your math book, or the top and the bottom of a cereal box. They will never intersect even though they go off in every direction forever, because there's a big gap in between them. And this plane up here does contain point A, so that is the only plane that we can use. And again, you can use any 3 of those points up there in an order, by the way. Make sure that you go clockwise or counterclockwise. Use any 3 points to label it. We're going to call it B, A, D. It's bad. Anyway, you could have also used D, C, B, A, D, C, C, B, A, and that's just going clockwise. You could have also gone counterclockwise and had all those backwards. It doesn't matter. Any of those 4 answers or any combination works. But again, that's the only plane that is parallel to EFG and contains point A. So now that you're hopefully you're able to identify 3-dimensional shapes. You're able to identify 3-dimensional objects, ideas, and be able to say, these 2 are parallel, these 2 are perpendicular, these 2 are skew, coplanar, not coplanar. The ability to visualize 3-dimensional objects and not only visualize the object, but able to analyze different parts of a 3-dimensional object is something that a lot of geometry students struggle with because, you've never had to deal with 3-dimensional objects this much. It always helps to draw them, by the way. If you can ever draw a 3-dimensional object, okay, that will help you kind of figure it out, because while you're drawing it, you're saying, okay, this is the side, this is the side, this is the top, this is the bottom, the back, and the front. You'll notice that we've got some dashes here. That means that those lines are hidden, meaning they are in the back of our image. And they're blocked out by the other faces that cover them up. You can also see this exact image on page 147 of your book. Let's keep going in our notes. And we're given a couple different postulates. Remember, we deal with definitions, theorems, postulates, corollaries. These 2 are parallel and perpendicular postulates. And postulate 13, or just the parallel postulate, says if there's a line, like line L here, and a point not on the line, like point P here, then there's exactly 1 line through the point parallel to the given line, which makes sense. We could draw 100 parallel lines to line L, but only 1 of those is going to contain point P. That makes sense. The same thing is true about perpendicular lines. If you have a given line, again like L, and a given point like P, then there's only 1 line perpendicular to line L that contains point P. And again, we could draw 1,000,000 perpendicular lines here. 1,000,000. Maybe even 2,000,000. I don't know. Maybe 1,000,001. But only 1 of those lines is going to contain point P and be perpendicular. There's only 1. Not a real tough concept. Either of these are. But it is important that you understand through any one point there's a given line, and it can be either parallel or perpendicular to a line that you've already established. Just understand that. We are going to talk about geography. If you ever are in collaboration with designing cities, street layouts, you have to think, where are my most accessible areas? Where do people need to go the most? Okay, now let's start dividing it up based on roads, parallel, perpendicular. This is a Google map of Davison. And what I want you to do is I want you to identify a pair of parallel streets and a pair of perpendicular streets. And then we're going to label those. Now, parallel, remember, run like that. Perpendicular, run like that. Now, you might be saying, well, Mr. Gentry, I have no way of knowing if they're perpendicular or not. What we can do, just for the sake of argument, is we can actually pull out a protractor. And we can say, all right, these 2 lines are perpendicular. They meet at a 90-degree angle, and so on and so forth. What we're actually going to do is just eyeball it. All I want you to do is say, that looks like perpendicular. You would not say that Greenway Drive and West Chelsea Drive are perpendicular. That doesn't even look close to a 90-degree angle. If you can kind of rough guess it, I'm good with that. And again, just for the sake of argument, we can grab our protractor. The first thing I want to do is identify a pair of parallel streets. 2 streets that run in the same direction and never stop. Or obviously a street will stop, but parallel being they run in the same direction and never touch. Now there's a bunch. One of the best ways to design cities and streets are parallel and perpendicular lines, because you can always access any part of the city through either a parallel or a perpendicular street. Now, don't get me wrong, not all cities are perfectly square. In fact, we can even see here that Davison has a big chunk out of it that doesn't allow certain streets to finish. Okay, in fact, these couple subdivisions over here require circular streets so that you can access all of them. But if we look down here at the main part of Davison, okay, call that Main Street, where the intersection of M15, let me use a different color here, the intersection of M15 and Davison Road meet, you can see there that we have a lot of straight up and down lines and lines that go left and right. A lot of streets that run up and down and a lot of streets that go left and right. That is where the majority of traffic, that is where the majority of businesses take place, and that's where the majority of parallel and perpendicular lines are used. And the bigger city you get, like let's talk about Detroit or Lansing, if you go over into like Las Vegas and stuff, you have the strip, you have the main drag where everything is off. Well, then you have parallel streets running off of that. Anyway, being able to identify them. Let's go through and let's actually just keep M15 highlighted because we're going to use that one first. Okay, so the first street we're talking about here is M15. Are there any streets that you can see parallel to M15? Well, there are a bunch. One of the first ones that jumps out to me is this one right here. It runs almost the entire length of Davison, and that's Genesee Street. I think there's only one S in Genesee. So those two are parallel. Now let's talk perpendicular. Excuse me. What two streets are perpendicular? I'll tell you what, we can even keep M15 as our main street that we're dealing with. Here's M15 still. Are there any streets that you can see obviously perpendicular to M15? And there's one that kind of jumps out right away because, again, it runs the entire width of our map, and that is Davison Road. Now, maybe used, some of these smaller ones like Dayton and Second, or Aloha and Second, stuff like that. Let's pull this guy over and just see exactly where. Right there, we can see that it's almost, move it up a little bit, there we go, almost perfectly perpendicular. Don't worry about that little guy, that means nothing. We can see that if Davison Road is our line, State Street runs 90 degrees straight up and down. So we could say that they're perpendicular. Again, designing cities, it's easiest because you want every part of the city to be accessible. Parallel and perpendicular lines are a huge, huge thing. Let's get this guy out of here. We don't need him anymore. The next thing we're going to talk about are 4 different types of angles formed by parallel lines. Most of the time they're parallel. In this case, they're not, but most of the time they are. In fact, coming up later in Chapter 3, they will be. There is something that you need to be familiar with first, and that is a transversal. A transversal is a line that intersects 2 or more coplanar lines. Really, it's just like, it's the intersecting line. Just think of it like that. In all 4 of these angles, the transversal that we're working with is line T. That's the transversal. So let's first look at this guy right here. We'll call it number 1. 2 angles are corresponding angles, corresponding angles, corresponding angles. If they have corresponding positions, well, that's like saying a hot dog is hot when you heat it up. Obviously, if they tell me that they're corresponding, they're in corresponding positions. Corresponding angles are angles that are in the same relative position. And let me show you what I mean by that. If I look at angle 2 here, angle 2 is projecting in a certain direction. Okay, think of it like the light beam on our projector that casts onto our Promethean board, or think of it like a flashlight beam. The position of the flashlight determines where the beam is pointed. angle 2 and angle 6 are in the same corresponding position, meaning they project in the same general direction. Now, corresponding angles have a very, very huge tell, meaning you can always identify them with a certain letter. That letter is letter F, and you should write this down because it's very, very important. Letter F is a perfect example of corresponding angles. This angle right here and this angle right here are corresponding angles. And if I look, oh, that was a horrible line. If I look at angle 2 and angle 6, I basically have an up-down F, or an upside-down F here. And angle 2 and angle 6 are in these two positions. If you can draw any type of F, whether it's upside down, maybe it's pointed to the left, okay? Maybe it's upside down and pointed to the left. That was bad. Those type of angles are all corresponding angles. So highlight or draw or whatever, like what we did, trace your angles, and if any way it is an F, that is a corresponding angle, an F. The second angle we're going to talk about, and again, you're going to be exposed to these a lot the rest of the year, so you'll get better and better at identifying them. The second type of angle is called an alternate interior angle, and the reason it's called an alternate interior angle is if we look at angles 4 and 5 here, they are on alternate sides of the transversal T. Alternate sides means they're alternate angles. The fact that they're inside these two lines means they're interior. Okay? Interior, and they're alternate, so that's why we call them alternate interior angles. There's another tell for alternate interior angles. Just like an F helps you identify corresponding angles, there's a tell for alternate interior angles, and it is the letter Z. If you have two lines cut by a transversal and you highlight those angles and they are in any type of a Z fashion, maybe it's a regular Z, maybe in this case it's backwards where it looks like this, okay, those are alternate interior angles. Letter F helps you identify corresponding angles. Letter Z, or any type of letter Z, maybe it's backwards, forwards, upside down. Okay, maybe it looks like that. Whoops, that's a W. Sorry. And they're like this. If it's any type of a Z, or maybe it's like the number 2, I don't really care. Those are alternate interior angles. Again, look at your picture and trace or highlight or however you want to those two angles. Let's do angle 5 and angle 4, and then let's just highlight them a little bit, and there, boom. I have this perfect representation of a Z, like Zorro. Any type of Z tells me that they're alternate interior angles. And again, the more you work with these, the better you'll get at identifying them. The third type of angle we're going to talk about is an alternate exterior. Alternate, meaning they're on opposite sides of the transversal, just like alternate interior, except exterior, meaning they're on the outside of our two lines. Just like 4 and 5 were inside or in between the two lines, these two are on the outside, so they are exterior lines, or exterior angles, excuse me. Not only are they on alternate sides of the transversal, they are on the exterior of our drawing, so they are alternate exterior. Alternate exterior don't have a letter to correspond with, but it is usually very simple to identify them. They look like those. And if you even want to make a small little drawing, draw a line, 2 lines intersecting those, and then just draw or just kind of highlight angles that are in complete opposite positions on the tops and bottoms. Those are alternate exterior angles. These letters and drawings, by the way, are a huge, huge help, not only on your homework, but on quizzes that come up and test reviews and tests, because you are not going to get away from corresponding alternate interior, alternate exterior, and consecutive interior angles. You are going to see these a lot more in geometry as we go through the year, and you're going to learn a lot more about them. So, alternate exterior angles. The fourth one that we're going to talk about is consecutive interior. Again, interior, meaning they're on the inside of the two lines that we're working with. I don't care what you want to label those. Maybe it's A and B. But if we look, 3 and 5 here are on the interior. That's why we call them interior angles. Consecutive means they're on the same side of the transversal. If this is my transversal T here, 3 and 5 are on the same inside. Okay, they're consecutive. They go right next to each other. Now, there's another tell for consecutive interior, and it is the letter C. If you can identify any type of letter C, okay, maybe it's a regular letter C, like over here, with these two angles, or maybe it's a backward C, like this one. But the two angles are still in the same position. Those are consecutive interior angles. Letter F identifies corresponding angles. Letter Z identifies alternate interior angles. Letter C identifies consecutive interior angles. And then we have the goofy one, the alternate exterior. And it's pretty easy. If they're not an F, Z, or C, then it's probably alternate exterior. Notice how they're, and make sure that you remember alternate exterior are on opposite sides of the transversal. That's what makes them alternate interior or alternate exterior. But these four drawings, excuse me. Let's redraw this guy. This sucks. Way to go, Mr. Gentry. Horrible drawing. 1 line, 2 lines, transversal, alternate exterior. There we go. These 4 drawings, even just the fact that you just kind of copied them down in your notes, is going to be huge in identifying them not only in the rest of the section, but the rest of the chapter and as we move forward in geometry. Again, you're going to find out certain things about corresponding angles. Not only should you be able to identify corresponding angles, but eventually you're going to learn that they're congruent. You're going to learn that consecutive interior angles are supplementary, or they add up to 180. Not yet, but eventually we'll get there. So those 4 new types of angles you really need to know. And there you have them right in your notes. You can always refer back to them. Let's practice identifying them a little bit. Example 3 wants us to identify all pairs of angles of the given type. Number 1 is corresponding angles. We have to identify corresponding angles. Well, if I go back in my notes, corresponding angles should form some type of F. So I'm going to remember that. I'm going to come back over here and I'm going to draw a little F right there. And if I can find 2 angles that form an F, those are corresponding angles. So the first thing I'm going to do is start looking at Fs. See if I can find an F somewhere. So I'm going to change my color first of all. And I'm going to draw an F right here. Boom, boom. Now it's an F that's facing down, but it's an F nonetheless. Let me do it one more time just so everybody can see what we're working with. Now if I look, again I'll go backwards, they should be in the same position. Corresponding angles should be in the same position of the F. They should project in the same direction. If I go over here, the 2 angles that I'm working with now are angle 5 and angle 7. And the reason I'm working with those 2 angles is they both project down and left a little bit. They're in the same position. They are corresponding. They form the F. They are in the same position. So I can say that 5 and 7 are corresponding angles. I'm going to try and identify more. But first I have to be able to draw another F. Let me go through this and erase this a little bit so we can see our diagram better. I need to draw another F. Now I can't draw one over here because I don't have that arm right there. I can't really draw one right here. So those two are out of play. We only have one line going that way. But I can draw another F going like this. There's my F. Now it's facing up. And the two angles that I'm working with are angles 1 and angles 3. Here's my F. There's the backbone. Here's the two arms. And the two angles that I'm dealing with are 3 and 1. That tells me that 3 and 1 are corresponding angles. Now there's two more pair of corresponding angles. There are two more F's that you can draw. And I'll give you one of them, unless you've already identified them, in which case, awesome. We're still using this line, but instead of 5 and 7, now our F looks like this. Again, here's my line, or here's my F. You might be saying, I don't see the F. Turn your paper over this way. Okay, let me redraw it. Here's my F, which means that these two angles are corresponding. Now it's backwards and pointing down, but it's an F nonetheless. Okay, if I stood this guy up, it would look like this. And then if I flipped him around, it would look like this. That's still an F. I don't care how you manipulate it, tilt your paper one way or the other. If it's any type of an F, they are corresponding angles. So angle 6 and angle 8, they're in the same position. They project like our light beam, like a flashlight, in the same direction, which means they're corresponding. So I can say that 6 and 8 are corresponding. Now there's one more set of corresponding angles for this diagram. Pause the video, take a second, and identify them. If you haven't already done so, I want you to look at angles 2 and 4. Angles 2 and 4 form an F. Now the F looks like this, and if we stood it upright, it would look like this. So there's our F. It's kind of laying down on its back right now. But angle 2 and angle 4 project in the same direction, so 2 and 4 are corresponding angles. All four of those combinations form some type of F. Now I'm going to go to number 2 and see if I can identify some pair of alternate interior angles. Now, alternate interior angles, I remember, form a Z. So I'm going to come back over here and I'm going to draw a Z. Actually, I shouldn't have done it like that. And so now I need to try and find Z's. Well, can't draw any that way or that way. Can't really draw any that way. Okay, those can't be Z's either. I just don't have enough lines. But I can get rid of some of these so you can see. I can draw a Z like this. You might be saying, well, that looks more like a lightning bolt. Whatever. Tilt your paper to the right. Twist your paper this way, clockwise, and you'll see that angle 2 and angle 7 are in the same position, projecting. Okay, they are on alternate sides of a transversal. So angle 2 and angle 7 form a Z. Kind of tilt your head to the left a little bit and you'll see the Z. It's actually kind of backward Z, but nonetheless. 2 and 7 are alternate interior angles. They are on alternate sides of the transversal, and they are on the interior of these two lines. So they are alternate interior angles. Well, because we did it that way, because we drew our Z like that, we can draw another Z. We can draw it like this. In which case, angle 6 and angle 3 are the alternate interior angles. They are on alternate sides, and they are on the interior of these two lines, which makes angles 3 and 6 alternate interior. Now there are two more pairs of alternate interior angles. Let me make sure I can find them first. I might be telling you wrong. No, that's it. There are only two pairs. Sorry about that. I don't know what I was looking at. But there are only two pair of alternate interior angles for this. There are only two Z's that we can draw. We can draw a Z like this. And then we can draw a Z like this. And those are the only two types of Z's that we can draw. So there are only two pair of alternate interior angles. Now let's talk about alternate exterior angles. And remember, this is the goofy one. This is the one that doesn't form an angle, or a letter. We can still identify it, though, because it does this. Looks like this. That's what I'm looking for. I'm looking for two lines, just like these two lines, cut by a transversal, and then they are on alternate sides of the transversal. Can you identify any? First of all, they're on the exterior of the two lines, and they are on opposite sides or alternate sides of our transversal. Right here. There's our transversal. Can you identify any angles that are alternate exterior angles? I hope you can actually identify two pair, because angle 1 and angle 8 are alternate exterior angles. 1 and 8. Now there's another pair that I hope just jumps right out at you. Hopefully it's like a elephant in the middle of the room. Angle 5 and angle 4 are also alternate exterior angles. They are on opposite sides or alternate sides of our transversal, and they are on the exterior of our two lines. So 4 and 5 are also alternate exterior. Now let's go to the last one, consecutive interior. Consecutive interior, if you look back at your notes, if you flip a page back, I'm going to wait till I'm done erasing, then I'll flip back with you. Consecutive interior forms the C. It was the last one that we looked at. Consecutive interior forms a C. They are on the same side of the transversal, and they're both on the inside of our two lines. So they form a C. Let me go back. And I'm looking for angles that look like this. They don't have to be pink or fuchsia or whatever you want to call that color, but they do form a C. So if I find my two lines, first of all, because that's what I need, there are my two lines. Cut by my transversal. Now I'm looking for angles that are on the same inside and are consecutive. Consecutive means they're right next to each other. Now there are two pair. Can you identify them? Maybe the first ones that you're looking at are 2 and 3. Angles 2 and 3. You might be saying that looks more like an H. Well, if I erase these, There's my C. Flip your paper to the right a little bit, like clockwise, or your notes to the right, and you can actually see that angles 2 and 3 form a C, which means that angle 2 and angle 3 are consecutive interior angles. Well, we can flip that right around, and instead of pointing up, we can have it point down. There's my 2 lines, cut by my transversal. Now if I flip my paper to the left, or counterclockwise, here's my C. It's kind of a goofy looking C, but it's a C nonetheless. And my 2 angles that I would be looking at are 6 and 7. They're on the same side of the transversal, and they are in between, or they are the interior of my 2 lines, which makes angle 6 and angle 7 consecutive interior angles. Let's review before you look at your homework. One of the first angles that you were dealt with was corresponding. Those form an F of some kind. Maybe it's to the right, maybe it points to the left, maybe it points down, maybe it points up, maybe it's backwards, whatever. Corresponding angles form an F. The next one you were shown were alternate interior angles. And those formed a Z of some kind. I don't care if it points down, points up, goes to the right, goes to the left. If it looks like a 2 or a Z, it's an alternate interior angle. The next one you were shown were alternate exterior angles. And those look like this. Remember that alternate exterior angles are the only ones that don't look like a letter, so we just draw a quick picture. They are on opposite sides of the transversal, and they are on the exterior of our 2 lines. The last angles that we talked about were consecutive interior angles, and they formed the letter C. They were on the same side of the transversal, which makes them consecutive. They are on the interior of our 2 lines, the top and the bottom here, which forms our C. We have the letter F for corresponding angles, the letter Z, or a number 2, depending on how it faces, for alternate interior angles. We have our alternate exterior angles, and we have letter C for consecutive interior angles. Let's take a look at your homework so you can practice identifying these 4.